Gracias, gracias. Hola a todos. Okay, cool. Okay, I'm gonna do this presentation in English. Okay, maybe for the one tomorrow, I'll try it in Spanish. I'll have more time to prepare maybe for that. But if you have questions or you don't understand anything, you could ask it in Spanish and someone here will help me translate. But today I'm going to talk about like why is, or they gave me the prompt, why is staking important for Ethereum is really what happened. And so I was like, okay, let me think about why staking is important for Ethereum. And like maybe taking a step back, like why proof of stake at all, why we have that. And like maybe taking a further step back, like why Ethereum? What do we want from Ethereum? Like what is Ethereum? And so the definition I have been using for Ethereum lately, like my new favorite definition, is Ethereum is a new type of computer. Right? Like you could say many different things about Ethereum. It's the next version of the internet. It's a layer for social coordination. But I like thinking about Ethereum as like a new type of computer. It's a new type of computer in like not like a computer in a physical sense, but a computer in the sense that you can write and develop applications and launch these applications on top of Ethereum. And these applications run on this computer just like any normal computer, except this computer has a few different properties. One of these properties is that Ethereum is open and globally accessible. This means that anyone around the world with an internet connection can use Ethereum, they can participate in Ethereum, and they can contribute to Ethereum. This is saying that like Ethereum is basically like neutral. It's neutral. It doesn't have any bias towards any specific region or any specific country. It's open to everyone, equally so. And that's one of the properties that make this a new type of computer. Another property is that it's verifiable. So anyone also around the world, but anyone can verify that the current state of Ethereum is correct, right? Like they can verify that it's correct, that it's accurate, that it should be, it is what it should be, and you can verify that the process to get there is also correct. And the third property is something called hardness, and this is basically to say that Ethereum makes strong commitments about its future, like about what its future will look like. That it will remain open and globally accessible far into the future. It will remain verifiable far into the future. And this is a new property. This is a type of property that we don't have on existing computers, right? And so like these three properties together give us a new type of computer where you can develop new types of applications. You can develop applications that are unstoppable, that are accessible by anyone around the world equally, that anyone can verify, that people trust. And like that's what's special about Ethereum, like is this new type of computer that gives us like an ability to create new types of applications. And so Ethereum depends on this consensus mechanism called proof of stake. Before we get into proof of stake, what is it that a good consensus mechanism gives, right? So I would say, maybe I'll go forward. Like, what is a consensus mechanism? A consensus mechanism is basically the way that Ethereum determines what its current state is. So, the consensus mechanism is the protocol or steps that are consistently followed to allow us to reach an agreement on the current state of Ethereum. This is basically to say that we all agree that Alice has 2 ETH and Bob has 1 ETH. We came to a consensus on this, we agree on this state, and how do we get to this agreement in Ethereum? We get to this agreement through a consensus mechanism. And so a good consensus mechanism will give us this guarantee, will allow us to come to consensus while also giving us a few of these properties. So when you talk about open and globally accessible, this means it should be censorship resistant. A good consensus mechanism makes Ethereum censorship resistant, meaning no one is blocked from using the network. Another aspect that a good consensus mechanism gives us is that anyone has the ability to participate in running the network. Another property that a good consensus mechanism gives us is that anyone can verify how consensus was achieved. And the third one is that, like, with this good consensus mechanism, there's a strong commitment that the above things will remain true, that we will continue to be in the future censorship resistant, that we will continue to be in the future verifiable for anyone to verify the current state. And so let us run through like some example, like just for fun, like consensus mechanisms that we could try, right? Like instead of like proof of work or proof of stake, there is no proof, just dictator. And it's just basically Justin Sun personally confirms all transactions. What he says is the current state is what goes, right? There's no disagreement. That is like a consensus mechanism to some degree. And it's really just that we come to consensus that what Justin says is true is true. And like that realistically doesn't work that well, right? Like we don't really end up with these properties here. It's not censorship resistant. He can easily block people from using the network. He can censor people. Not anyone has the ability to participate in running the network. So not a good type of consensus mechanism. Another consensus mechanism that maybe is more popular, or that people have heard of before, is called proof of authority. And this is basically to say, like, let's give power to a group of 20 high-power people and companies, and they can take turns processing transactions, and we trust that at least 50% of them are honest and correct. And in reality, like, this works okay, but not really that great, right? It doesn't give us a lot of these properties that we want. It doesn't give us censorship resistance. Like, I don't trust that group of 20 companies or 20 people any more than I would trust my banks today or many governments today. And like, we're building these systems because we basically don't trust these governments. We know that they don't work in our interest sometimes, that they fail, that banks fail, that organizations fail. And so we need to be stronger and better than that. And proof of authority systems don't really do that, right? They don't really give us many more guarantees than our existing systems. So that's like one example of a consensus mechanism. Maybe another one is proof of computer. So like, let's think about like, all right, let's say we wanna make a system where anyone in the world can participate. It's not proof of authority. It's not dictator Justin Sun. It's anyone in the world can participate in running this network. We just require that they have a computer access. And like, this kind of sounds nice at first, right? Like, okay, then anyone can participate. They don't need to put any money down. They're just like participants in running the network. And like, it sounds nice until you realize that things like this exist in the world, and one person can be controlling 20 computers or thousands of computers. And as you control more computers, your influence over the system increases. Meaning like this system doesn't end up working out in the end. So like, yeah, the real problem here is that this has no Sybil resistance. So we're not able to identify when one person is pretending to be multiple people. So Sybil is basically a copy, like up there, Sybil. So we need a consensus mechanism that has Sybil resistance built into it, right? Where we can identify, or we can at least prevent or minimize people from pretending to be multiple people and having undue or like over influence in the system, in the consensus of the system. And so like, here's another example of a consensus system. And now with Sybil resistance, right? So like, this is another fun example. Proof of personhood. Allow anyone who has a computer and who too is a unique person to participate in consensus, right? So if they have a computer and we can prove that they are a unique person, then we'll let them run a node. We'll let them process transactions and help us determine what the state of Ethereum is. And it actually doesn't sound like that bad of an option up front. Like, it really doesn't sound like that bad of an option until we realize it's really hard to know who is a unique person. Like, we can try to rely on government IDs, but those are easily fakeable. And then if governments had influence over a system like Ethereum, just by printing more IDs, we would certainly see that happen. And so it becomes actually really difficult to build a system that does this, that is proof of personhood. And even though, if we could, it would actually probably be an okay system. Unless someone started introducing bribes, which is another problem for the system, right? Like, if we did proof of personhood, everyone individually was able to confirm they were a unique person, participate in running Ethereum nodes, and like, that would be okay, but then we'd start to see probably people bribing each other, right? And probably big entities with a lot of money bribing people to have them manipulate the transactions in their favor. So this is an interesting problem. I think we could figure it out. Maybe it's like, I really actually maybe think this is the next step beyond proof of stake, like proof of work, proof of stake. Maybe it becomes proof of personhood if we're able to figure this out. But it's a challenging one. So, all right, example consensus mechanism number 5. So let's recap. We want anyone to be able to participate in the consensus of Ethereum, right? To help us determine what is the current state of Ethereum. We don't want one person to pretend to be multiple people or to have undue influence over the system. We don't want bribes to really be easy or feasible or make sense in the system. And we need to use something that, like, many people have that is hard to replicate, maybe that's scarce and which people value highly. Like, what is something that people value highly? And so basically, what we talk about here is capital. So in the last example, we say proof of capital. Some would call it proof of work. We call it, or we use one called proof of stake. But in both cases, what both proof of work and proof of stake are, they are really proof of capital. In proof of work systems, what happens is you prove that you burn money, right? You're proving that you burn money. In proof of stake, you prove that you have money by locking it up. And in both these cases, you have a system that is proof of capital. And so what's good about this is that, not like, as much as we might want to duplicate our capital and pretend like we have more money than we do, it's really hard. We can't do that. And so you can't really fake like you have more influence than you should. And bribing doesn't really work out either, because I could say, hey, if you give me 32 ETH, I will give you like 1 ETH, but you're not going to do that because that's a bad bribe. And so bribing doesn't really work out. And you end up with an interesting consensus. You end up with a relatively decent consensus mechanism, right? It's not like perfect, right? Not everyone around the world has equal access to capital, but it is relatively well distributed around the world. It's not concentrated in one specific country, one specific region. And it is relatively neutral, all things considered, where the capital ends up. And so this is basically how we end up with these concepts of proof of work and proof of stake. They're both proof of capital, and they're both, basically what we use to prove, this is our Sybil resistance mechanism for our consensus mechanism. So this is how Ethereum comes to determine its current state. With proof of stake, basically it helps. Proof of stake is basically the Sybil resistance mechanism that prevents one person from pretending to be many people and taking too much influence over a system. And with this type of consensus mechanism, we end up getting some interesting properties that allow us to have this, or help us with some aspects of this new type of computer, right? So it gives us some censorship resistance. It allows anyone to have the ability to participate in running the network. It allows others to verify how consensus was achieved, and it gives us also relatively strong commitments that those things will remain true in the future. And so, yeah, I also wanted to cover some benefits of proof of stake. Actually, this slide was in Spanish already, so I just copied it over from when I did a presentation before. Because I mean, this whole day is about privacy, right? And so I think like two things I wanted to touch on that are benefits with proof of stake is that that proof of stake arguably is much more decentralized than alternatives like proof of work, right? So in proof of work, how do you become like an independent miner? You have to invest a lot of money to become an independent miner. You have to invest, in some cases, like millions of dollars to become an independent miner. In most cases, if you want to contribute to mining in proof of work, you have to join a mining pool. And in that case, you're not really independently contributing to the security of the protocol. Whereas in proof of stake, you only need to have like a small little computer. And actually, yeah, and you need to have right now 32 ETH, but perhaps this will decrease in the future, maybe not. But even if so, like we have liquid staking tokens and we have DVT, which maybe NT will touch on later, about how more people can get involved in staking. And yeah, I would say it's a little bit more decentralized in that sense. I would also say it's probably more resistant to censorship and also like a little bit more private in this sense, right? So like if you are a miner, if you're like a large mining entity, you're likely to be able to be discovered relatively easily. And like this is not necessarily true with staking, right? With staking, you can have a small little computer. So like this is a node that I had running in Bogota a couple years ago. And like you can have a small little computer like that running somewhere in your house, hidden behind a bookshelf, and it could be really hard for people to identify where you are. And so I think I think proof of stake is more resistant to censorship for that reason. And yeah, like this is one example of police in Malaysia a couple of years ago finding a bunch of Bitcoin miners and then crushing them because I mean they were able to track down how much electricity this person was using, and they didn't like it. So yeah, last two things I'll cover on are like misconceptions around proof of stake. So the first one is basically that proof of stake is a rich get richer system, and proof of work is not. I would say this is not true, right? Like in most things in the world, there is like proportional returns, right? So when you lend your money out, you will earn an interest rate on that money. And in the case of proof of stake, the interest rate you earn is essentially like pretty constant. Whereas in proof of work, if you have more money, you'll be able to make more money faster, right? So there are economies of scales in proof of work. Like if you have a few $1 million, you're able to create a mining farm somewhere where there's cheap electricity. You're able to make deals with the governments. You're able to make more money faster than if you have a lot of money and you stake it. You're just going to earn the same percentage as everyone else. And so proof of work or proof of stake is not a system where the rich get richer any more than most systems today. And proof of work actually is where the rich get richer faster. And the last one is that proof of stake does not mean that stakers control the governance of Ethereum. So Ethereum is governed by informal governance, meaning that there's a community of people around the world that work on upgrades and research to Ethereum. Many believe that, or some believe that proof of stake means that the stakers are the ones that determine the upgrades that happen to Ethereum, and this is not true. This is not true with Ethereum. This is true with some other blockchains, like Tezos has on-chain governance that is powered by its validators, but this is not true with Ethereum. Ethereum has informal governance similar to Bitcoin. and that's something that I don't think will change for a long time. And yeah, that's basically all I had. You'll hear a lot more about staking in the next coming talks. This is DevCon, in case you're interested in coming. It's in Bangkok in November. It'll be a great reunion among many people from around the Ethereum ecosystem around the world. And so hope to see you there. If you come to the talk tomorrow, I'll show a QR code that has some discount codes. So show up 10:30 tomorrow on the main event, and I'll have that prepared by then. But that's all I have for today, so thank you all so much.